For as long as mankind has been observing the heavens, we have been fascinated by the possibility that other worlds, much like Earth, might contain living organisms. While our visits to the moon have taught us that it is completely barren and uninhabited, other planets in our solar system show much potential. Venus, for example, could harbor life in its cloud layer. Europa and Enceladus could be teeming with life in a subsurface ocean of liquid water. Even Titan's liquid hydrocarbon lakes are a fascinating place to search for exotic microbes. If you enjoy our videos, feel free to support us with a thumbs up, subscribe to Simply Space, and stay tuned for future videos. Life on the red planet? By far, the most intriguing possibility is the red planet, Mars. This smaller, colder, and more distant cousin of Earth certainly had a humid past, with liquid water flowing on its surface for more than 1 billion years. Various lines of evidence point to the plausibility of life on Mars, not only in the prehistoric past, but possibly today as well. With the information we have received from various orbiters, landers, and rovers, we have made a number of fascinating discoveries on Mars. We see dried riverbeds and evidence of ancient glaciers on the Martian surface. Tiny hematite spheres have been found on Mars, as well as ample evidence of sedimentary rocks that form on Earth only in watery environments. In addition, the Mars rover has observed solid subsurface ice, snow, and even frozen surface water on Mars in real time. It has even been shown that saline surface water is likely actively flowing down the walls of craters, although this finding is still highly controversial. All the factors necessary for life on Earth were also abundant on early Mars, including a dense atmosphere and liquid water on its surface. Although Mars does not look like it is teeming with life today, there are 3 pieces of evidence that earlier, or even present-day life may be possible and cannot be dismissed out of hand. Evidence number 1. The first convincing evidence came from instruments aboard NASA's Viking lander in 1976, which conducted 3 biological experiments: a gas exchange experiment, a labeled release experiment, and a pyrolytic release experiment, followed by a gas chromatograph mass spectrometer experiment. The labeled release experiment returned a positive result when performed on both Viking landers, but only the first time. All other experiments came back negative. The test results imply that Mars had an atmosphere similar to Earth. Evidence number 2. The second piece of evidence came when a fragment of a Martian meteorite, Allen Hills 84001, was recovered on December 27, 1984. As it turned out, about 3% of all meteorites that fall to Earth come from Mars. But this one was particularly large, weighing almost 4 pounds. It originally formed on Mars about 4 billion years ago and landed on Earth only about 13,000 years ago. A 1996 look inside revealed material that could be the remains of fossilized organic life forms, although they could also have been formed by inorganic processes. Evidence number 3. Finally, the third piece of evidence was provided by NASA's newest Mars rover, Curiosity. As the seasons changed on Mars, Curiosity detected burps of methane emanating from specific subsurface locations, but only at the end of the Martian winter and with the onset of the Martian spring. Again, this is an ambiguous signal at best, as inorganic geochemical processes could be seasonal and lead to the release of methane. But organic biological processes could also cause this. 5 possibilities for life on Mars. If we look at all the evidence, there are 5 possibilities for the history of life on the red planet. Mars could have always been a barren world, or it could have been a world where life thrived for a time and then became extinct. Another possibility is that life could still exist on it even today, which would be truly stunning news for all of humanity. the following scenarios are quite possible. 1. There never was life on Mars. Although it has the same raw materials as early Earth and similar water conditions, the necessary circumstances to allow life to form simply never occurred on Mars. All the geological and chemical processes that occur inorganically did take place, but no organic activity. Then, a little over 3 billion years ago, the Martian atmosphere was stripped by the sun, drying up any liquid surface water and leading to the present appearance of Mars. This is the most conservative viewpoint and would require that all 3 alleged positive tests have either inorganic or impurity-based resolution. This is entirely possible and remains, in the minds of many, the default assumption. Until very convincing evidence emerges that clearly points to past or present life on Mars, this is likely to remain the leading hypothesis. But seasonally frozen lakes do appear everywhere on Mars, indicating a water-rich past. 2. There was early life on Mars, but it died out. In many ways, this scenario is just as possible as the previous one. It's very easy to imagine that a world with a dense atmosphere similar to early Earth, with stable liquid water on its surface, continents rich in geological diversity, volcanoes, a magnetic field, a day similar in length to ours, and temperatures only slightly cooler than those of today's Earth, could lead to the flourishing of life. However, the loss of Mars's atmosphere had profound effects on the planet and may have led to the extinction of all life on Mars. Drilling into the sedimentary rocks of Mars and searching for fossilized life forms, or even metamorphosed carbon-rich inclusions, could potentially provide the evidence necessary to confirm this scenario. 3. Mars harbored early life, and it still persists in a mostly dormant form beneath the surface. This is the most optimistic, but still scientifically defensible, view of life on Mars. Perhaps there was life early on, and when Mars lost its atmosphere, a few extremophiles remained in a kind of frozen limbo. If the right conditions emerged, perhaps underground, where liquid water can flow, that life could reawaken and resume its critical biological functions. If that is the case, then there are still organisms beneath the Martian surface, perhaps in the shallow sand just a few feet or even inches below the Mars rover. It's likely to be only single-celled life, perhaps not even reaching the complexity of a eukaryotic cell, but life on a world other than Earth would still be a revolution for science. NASA's Perseverance rover, successfully launched on July 30th, 2020, will collect important soil samples to test this hypothetical scenario. 4. There was no life on Mars until pieces of the Earth hit it. 65 million years ago, a very large, fast-moving body slammed into Earth, creating the Chicxulub crater and throwing up enough material to envelop the planet in a cloud of debris, resulting in the 5th major mass extinction in Earth's history. And as with many massive impacts, this one likely sent small pieces of the Earth into space, just as impacts on the Moon or Mars sent meteorites through the solar system, some of which eventually landed on Earth. The impacts sent material from Earth to other worlds, including Mars. It's extremely plausible that organisms from Earth got to Mars and began to reproduce, whether they thrived or not. Perhaps someday we will be able to explore the entire history of life on Mars and find out if possible life on Mars is descended from existing life on Earth. This is an intriguing possibility that cannot be easily dismissed. 5. Our modern space program spread Earth-based life to Mars. After all, Mars was a barren, lifeless planet for a long time, at least for billions of years, until the dawn of the space age. Eventually, material from space that was not 100% decontaminated or sterilized landed on the Martian surface, bringing with it modern terrestrial organisms in the form of stowaways. This option is the ultimate nightmare of astrobiologists. That there is a fascinating history of life to be discovered on another world, but we contaminate it with our own organisms before we learn the true history. The worst-case scenario might have been that simple life of Martian origin survived on Mars, but that terrestrial life displaced it so that it quickly died out. This very real fear is why we are often so reluctant to explore other planets and alien worlds from a biological perspective. The Mars rover Curiosity. Nevertheless, the Mars rovers, most notably the Curiosity model, remain key allies in the exploration of Mars. In 2013, the robot took a rock sample by drilling a hole about a half-inch wide and 3 inches deep. The US space agency NASA announced. The rock samples would be evaluated the coming day. The sample revealed that there was water with a relatively neutral pH, laying a foundation for microbial life. Do you think Mars could become a second Earth for humanity, and we might even live there one day? Feel free to leave us your thoughts in the comments.